Men's heights are normally distributed with a mean 69 inches and a standard deviation of 2.8 inches. Boeing 757s have doors with a height of 72 inches. What percentage of adult men can fit through the doors without bending? And then we'll answer, what doorway height would allow 98% of adult men to fit without bending? So for the first question, we have to take 72 inches, convert that into a z-score, and then we could look up on our table the percentage of men, the percentage of z-scores at that point. That would be below our z-score. And that would tell us the percentage of adult men who are less than the height of the doors. In other words, the percentage of men who are less than 72 inches. So to start out, we'll convert 72 into a z-score by taking our z-score formula and saying 72, that's a 72, minus our mean, which in this case is 69 inches, and dividing by our standard deviation of 2.8 inches. Throwing all this into the calculator gets us 0.11. So I'm going to go to the normal distribution table and look up a z-score of 0.11 and find out what percentage is less than 0.11. That will tell me the percentage of men who are under 72 inches. So on the table, I said I'm looking for 0.11, which tells me that I've got 0.5438 less than the z-score 0.11. That means that about 54% of men are below, or rather 54% of men could fit through the doors without bending, the doors that are 72 inches. The second question, what doorway height would allow 98% of men to fit without bending? Well, this first requires us to find the z-score that's associated with 98%. So we'll go to the table and we'll look up 0.98 in the table and get the z-score for 0.98. So again, I'm looking for 0.98 in the probability area, which is the main area of the table, and then I'll find the z-score associated with that. So I see I've got 0.9826 here. I've got 0.9817 going down. I'm between 0.9798 and 0.9803. So the question is, which one do we choose? Since 0.9798 is only 2 ten-thousandths away from 0.98, and 0.9803 is 3 ten-thousandths away from 0.98, we're going to pick the one closer, that is 0.9798. But of course, we're looking for the z-score. So that is, my z-score is over on the left, a 2.0, and going across the columns, I know the first column's 0.00, 0.01, 2, 3, 4, 5. So the z-score associated with 0.98, we're going with 2.05. Now we've still got to convert this into a height. So let's look. So we found our z-score to be 2.05, and we need to convert this into a door height that would allow 98% of men to fit through, because the z-score has 98% to the left of it. So we would want a door height that would allow have 98% of men below that height. So to do that, we're going to take our formula for converting z-scores and plug in 2.05 times our standard deviation, which we said was 2.8, and add the mean, 69 inches, And that gets us, plugging this into our calculator, gets us about 74.74 inches. So if our doorway was 74.74 inches tall, about 98% of men could fit through that door without bending.